The map of our world is about to change. And I'm not talking about China breaching boundaries. I'm talking about the continent of Africa splitting into two.
In the heart of Africa, a dramatic transformation is taking place, altering the face of our planet. Less than 20 years ago, the Earth began to fracture, tearing through territories and even dividing a man's home in two. Africa is slowly tearing apart, hinting at the birth of new lands and seas. But what mysterious forces are causing this massive shift? How will this reshape the future of not just Africa, but the entire world? As all this occurs, can humanity do anything at all? Dive deep with us into this captivating phenomenon, uncovering secrets most remain unaware of. 3 burning questions will be addressed. What's truly driving Africa's split? How will this tectonic dance reshape global geopolitics? And could other continents be next? Let's find out. In 2005, captivating images surfaced, unveiling a breathtaking spectacle in East Africa, a continental rift. Picture this, a massive stretch of land, seemingly unyielding and permanent, slowly tearing apart. But how? And why? Our planet has a secret. It's alive in a way that's both mystifying and majestic. Continents aren't just lifeless, static land masses. They're dynamic and constantly moving. Once upon a time, hundreds of millions of years ago, Earth was a quiet, unified land, a supercontinent called Pangaea. Imagine, all the lands we know today were snuggled up together, surrounded by a vast ocean named Panthalassa. But then, something incredible happened. The Earth's crust, affected by the intense heat from below, began to tear apart, rearranging itself into the beautiful patchwork of continents and oceans we recognize today. And this dance isn't over. Our continents, seated on around 15 to 20 massive tectonic plates, are continuously moving. It's a slow, mesmerizing waltz directed by the intense heat of Earth's core. This is called plate motion, or tectonic shift. Today, as we witness the rift in East Africa, we're essentially getting front-row seats to the next chapter of Earth's grand continental performance. According to NASA's Earth Observatory, the Somalian plate in East Africa is slowly drifting away from its big brother, the Nubian plate. Some people like to call them the Somali plate and the African plate, respectively. Intriguingly, both these plates aren't just distancing themselves from each other, but they're also moving away from the Arabian plate up north. Imagine 3 close friends gradually drifting apart. These friends meet at a place called the Afar region in Ethiopia, where they form a fascinating Y-shaped rift. The Geological Society of London labels this rift between the Somalian and Nubian plates as the East African Rift. Picture this, a stunning stretch of valleys, almost 2,175 miles long, extending from the Red Sea all the way down to Mozambique. The process of Africa splitting into 2 continents is largely driven by the rifting of the East African Rift System, EARS. This tectonic boundary stretches from the Afar Triple Junction in the northeast down to Mozambique in the south. As tectonic forces pull the African plate apart, magma rises to create a new crust, pushing the continents further apart. With the continuation of this process over millions of years, the split will eventually become significant enough to allow ocean waters to flood in, leading to the formation of a new ocean and splitting the African continent. Potential polar shifts, or geomagnetic reversals, occur when the Earth's magnetic poles switch places. While these events have occurred multiple times in Earth's history, their direct contribution to tectonic processes is not yet clear. However, it's hypothesized that polar shifts could have indirect effects on the planet's lithosphere. As Earth's magnetic field weakens during a polar shift, it could influence mantle convection, possibly affecting tectonic plate movements. If such an event caused an increase in tectonic activity in the EARs, it might accelerate the rifting process. However, more research is needed to understand the relationship between geomagnetic reversals and plate tectonics. Supervolcanoes, on the other hand, can have more direct and observable effects on continental structures. The formation of a supervolcano requires a significant upwelling of magma from the mantle, creating a large magma chamber near the Earth's surface. The immense pressure from this magma can cause the crust to bulge and fracture, potentially influencing nearby tectonic boundaries. If a supervolcano were to form near the East African Rift, the immense volume of magma and subsequent eruption could expedite the rifting process by introducing more molten material and altering regional tectonic stresses. This, in turn, could quicken the separation of the continents. While the primary driver of Africa's potential split is the ongoing divergence at the East African Rift, external factors like potential polar shifts and supervolcanoes could play roles in modulating the pace of this continental drift. Both phenomena introduce a level of uncertainty into geological forecasts and remind us of the dynamic and interconnected nature of Earth's systems. Now, here's where it gets even more awe-inspiring. If this Somalian tectonic dance continues and it breaks free entirely from the Nubian plate, we could witness the birth of a new continent. It's like witnessing the epic split between South America and Africa millions of years ago. But hold on to your excitement. Such a split could take 5 to 10 million years. But what if only parts of the Somalian plate separate? The new sea will also form a new land that might include countries like Somalia, Eritrea, Djibouti, and parts of Ethiopia, Kenya, Tanzania, and Mozambique. Some regions might even get lucky. Think of landlocked countries like Ethiopia and Uganda suddenly getting a coastline. The perks, a boost in trade, production, and maybe even tourism. However, we must keep one important detail in mind. This grand process is slow. The rift, though visible, is widening at a pace of about 1/4 of an inch every year. To put that in perspective, it's like watching your toenails grow. But all of this begs an important question. How do these huge cracks, known as rifts, form on our planet's surface? The creation of these rifts has always been a hot topic among scientists. Picture this. Deep inside the Earth, intense heat rises, creating something spectacular: thermal bulges. You can spot these in places like Kenya and Ethiopia, looking like magnificent elevated highlands on a map. As these bulges form, they stretch the Earth's crust, causing it to crack and fracture. Imagine pulling apart a candy bar and seeing it break into pieces. That's what's happening to the Earth's crust. But what causes these bulges? The answer lies beneath our feet. Mantle plumes, hotter than the magma around them, push against the Earth's crust. This heat causes the crust to melt and thin out, leading to those awe-inspiring bulges. When these plumes are really active, they can also lead to massive volcanic eruptions. Picture lava flowing over vast areas, much like water during a flood, pouring from the fractures instead of individual volcanoes. Scientists call these flood basalts. One of the most magnificent sights resulting from these processes is the Rift Valley. Unlike the valleys formed by rivers or glaciers, these are birthed when giant tectonic plates pull away from each other. Sometimes, where 3 tectonic plates meet, magic happens. 2 of these plates might split and create an entire ocean, while the third, a failed rift, turns into a rift valley. Did you know the Atlantic Ocean owes its existence to such a phenomenon that began near Africa? Underneath our vast oceans, similar wonders are unfolding. The ocean floors have rift valleys too. Here, when plates pull apart, molten rock from the Earth's core rushes up, meeting the cold ocean water and forming new seabeds. A striking example is the Mid-Atlantic Ridge, where 2 colossal plates are slowly moving apart every year. Over tens of millions of years, the Mid-Atlantic Ridge has sculpted valleys as broad as 9 miles. But it's not the only artist at work. The Pacific Ocean plays host to the East Pacific Rise, where the powerful Pacific Plate dances away from its neighboring plates. As they part, the stage lights up with hydrothermal vents, shooting out superheated water from deep within the Earth's crust. It's like an underwater fireworks show. Now imagine a rift valley so grand that it tears through continents and is famous worldwide. Enter the Great Rift Valley. This monumental fracture snakes its way from the heart of the Middle East, winding down all the way to the warm landscapes of Mozambique. But this isn't just any rift. It's alive. The Great Rift Valley pulsates with volcanic energy, sprouting hot springs, geysers, and even rumbling with the occasional earthquake. The East African Rift, a part of this vast chasm, splits into 2 dramatic branches, the Western Rift and the Gregory Rift. Picture this: volcanoes lining these rifts like beacons, from Ethiopia's to Ale to the towering presence of Mount Kenya. While some of these volcanic giants, like Mount Kenya, have long since fallen into a deep slumber, others still roar with fiery might. Have you heard of Mount Kilimanjaro in Tanzania? It's not just a dormant stratovolcano, it's the tallest peak in Africa. The Western Rift is another masterpiece, also known as the Albertine or Lake Albert Rift. It's not just a rift, it's a treasure trove of biodiversity. Majestic snow-capped mountains, sprawling savannas, dense highland forests, and shimmering lakes. It's nature's own Eden in Africa. Meanwhile, the Gregory Rift has a story of its own. Named after the geologist who unveiled its secrets, it begins at the crossroads of the Red Sea and the Arabian Sea, leading the way down to Mount Kilimanjaro. And at its heart, the Afar Triple Junction, a place of pure geological wonder. Here, the Earth is literally tearing apart in three directions. The Horn of Africa teeters on the edge, with the Red Sea on one side and the Gulf of Aden on the other. As the rifts grow, there's a possibility so awe-inspiring. The Gregory Rift might deepen so much that the Arabian Sea fills it up. Imagine the Horn of Africa as an island, standing proud like Madagascar or New Zealand. What a world we live in, where even the ground beneath us tells tales of wonder and majesty. Both these branches, Western and Gregory, were birthed from the same geological process, yet exhibit wildly different personalities. It's like two siblings raised in the same home, but one is a passionate artist, while the other is a deep thinker. In the Gregory Rift, the Earth's fiery temperament is on full display, with volcanic outbursts painting the landscape. Conversely, the Western Rift, deep and introspective, houses vast lakes within its basins. And not just any lakes, but the likes of Lake Tanganyika, the world's second deepest lake. There's also Lake Malawi, where the Earth's crust grumbles, releasing basalt eruptions and creating ever-shifting crevices. For geologists, the East African Rift isn't just another geographical feature, it's an open book revealing secrets of how ocean basins are formed on land. While most of Earth's rifts are either hidden beneath layers of sediments or submerged underwater, this one remains accessible, almost inviting scientists to unravel its mysteries. A living laboratory, if you will, to witness a rift in action. Did you know that lakes are frequent guests in the story of rift valleys? These rift lakes come to life when a rift valley gets a thirst for fresh water. For instance, when the North American plate was stretching itself out 1 billion years ago, it created a deep valley. Over time, this rift quenched its thirst, giving birth to what we now know as Lake Superior, perched atop one of the world's oldest rift valleys. Now let's embark on a journey to Siberia, where Lake Baikal, the world's oldest and deepest freshwater lake, awaits. Nestled over the Baikal Rift Valley, its depths plunge an astonishing 5,387 feet. Over 25 million years, soft sediments have settled like memories on its bed. So deep is this lake that its true floor, hidden beneath those sediments, lies more than 3 miles below. And it's not just about depth. Lake Baikal is a reservoir of fresh water so vast, holding a staggering 5,700 cubic miles, it's unparalleled anywhere on Earth. But rift lakes aren't just about depth and expanse. In the Jordan Rift Valley, the Dead Sea challenges our understanding of low. While not the deepest, its surface stands at a jaw-dropping 1,407 feet below sea level. And it doesn't stop there, delving another 997 feet into the Earth. The Dead Sea and Lake Baikal are like chalk and cheese when it comes to rift lakes. You see, the Dead Sea isn't a genuine rift lake because the rift underneath didn't fully form. Instead, it's part of the mysterious Dead Sea Transform, a zone where Earth's tectonic plates dance in a complicated tango. Speaking of rift lakes, have you heard of the magnificent ones in the East African Rift Valley? Stretching all the way from Ethiopia to Malawi, these lakes are nature's treasure chests. They're bursting with life, from creatures seen nowhere else to mesmerizing colors. Think of them as Mother Nature's jewelry boxes. Lake Tanganyika, for instance, isn't just another lake. 4 countries, Burundi, Congo, Tanzania, and Zambia, proudly share its coastline. Dive into its waters, and you'll meet hundreds of unique tickled fish found only here. And then there's Lake Natron in Tanzania. It's not your usual blue or green lake. Instead, it flaunts a ruby red hue. No, it's not because of its rock formation, but due to pink, salt-loving bacteria thriving in its salty embrace. Nature surely knows how to throw a color party. Moving further, we have Lake Malawi, or as some call it, Lake Nyasa. It's the world's third deepest freshwater lake, sitting comfortably in the East African Rift Valley. While its basin buzzes with life, its waters hide a secret. It's home to the most diverse fish species on the planet, with numbers ranging from 800 to 1,000. The East African Rift isn't just about lakes. As it slowly but surely continues to reshape Africa, it's grabbed the attention of everyone, from curious geologists and ecologists to vigilant governments. But there's more. This rift is a portal to our past. Dubbed the cradle of humanity, it has unveiled many ancient human fossils, offering glimpses of our earliest ancestors. It's not just a rift, it's a storybook of our shared history. Every turn of this soil holds secrets, with scientists constantly making groundbreaking paleoanthropological discoveries. Imagine stumbling upon Lucy, a hominin skeleton over 3 million years old, nestled in Ethiopia's landscape. Or the Turkana boy, another intriguing find, close to 2 million years old, peeking out from Kenya's grounds. But it's not just about the relics of the past. The very structure of this rift tells a tale of continents tearing apart, potentially forming new oceans. It's believed that the unique evolution of this rift created a haven perfect for life to flourish. But nature always demands balance. As the rift shaped East Africa, it made the region vulnerable to climatic shifts. Picture alternating wet and dry seasons, demanding adaptability from all life forms. Could this be why our ancestors evolved, becoming two-legged, smarter beings, adapting to an ever-changing world? Yet the East African Rift isn't just an archive of the past. It pulsates with energy, literally. Amidst the maze of volcanic and tectonic activity lies a treasure trove of potential power. There's talk of harnessing this energy, with the United Nations Environment Program proposing a geothermal energy scheme. Think about it, tapping into the rift's underground heat, transforming it into electricity through steam wells. One such well could power a staggering 5,700 homes. This could light up lives, especially for those who've never known what it's like to switch on a bulb. However, every treasure has its guardian. For the rift, it's the unpredictable volcanic and tectonic forces. Rising water levels are just a tip of the iceberg. The discovery of oil around a lake hints at further chapters in the rift's tale. Contrast this potential with the ground reality. The people living by the rift face intense challenges, with malnutrition and unpredictable natural forces shadowing their lives. Yet amidst these contrasts, the scientists' passion remains undimmed. Africa's geological future is a topic of intense scientific discussion. This rift phenomenon, while primarily geologically driven, intertwines with the pressing issues of global warming and climate change. The interplay between tectonic activity and climate change is complex. On one hand, the physical splitting of the continent is fundamentally due to the movement of the Earth's lithospheric plates. However, the effects of global warming and climate change can influence the dynamics of this process. For example, increased rainfall, predicted as a consequence of a warming climate, could lead to greater erosion along the rift. This could, in theory, speed up the widening of the rift, although the precise implications remain a subject of study. Moreover, the potential for rising sea levels, a direct result of global warming, could accelerate the inundation of the Rift Valley. As the world's polar ice caps melt and ocean waters expand, low-lying areas around the world face the risk of submersion. In the case of the Great Rift Valley, rising sea levels could flood the region much faster than if the process was driven by tectonics alone. This would pave the way for the creation of a new ocean, fundamentally changing the topography and geography of the continent. Political stances on environmental topics can also play a role in this complex interplay. African nations, like many around the world, grapple with the challenges of balancing economic growth with environmental sustainability. The exploitation of natural resources, deforestation, and land use change can alter local environments. These changes, in turn, can exacerbate the effects of global warming, such as changing precipitation patterns, which might have localized impacts on the rift's dynamics. Furthermore, As the rift continues to evolve, there may be socio-political implications. Resources located on the rift could become points of contention, and the physical division of territories could lead to boundary disputes. Thus, political stances on environment, resource management, and territorial rights will be pivotal in shaping the continent's response to its changing landscape. Thank you for being with us. Make sure to watch the next video on your screen. It's fantastic.